Who's absent? Normal people? Yana, Bailey.
You know Russian, right? Okay. How many words are? How many letters are in the alphabet?
There's like 6 more than the
Russian alphabet.
yeah, because you have just like you have 6 different.
Yeah, okay. So the so you know the Russian words. They have like the letter.
Oh, the little arrow, that means it's harder, right? It's like a harder sound. So it's like, if you have a duh and you have an arrow over it, it's
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44 is what I'm counting.
That's the early, not Russian.
Oh, I got you.
Yeah, because you don't have
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's a bunch.
Yeah. You don't have that. You don't have that. You have that. No.
All right, find your seats. Let's go.
Oh, they're just in time. Nice.
Can you go to the end of the class?
No.
I don't speak Adidas.
All right, Matt said he had problems on 10 through 13. So we'll look at a couple of those, 10 through 13. 10 through 13. I'm sure it's a picture or something. I'm listening. All right. I'm going to do number 12. This is number 12.
Oh yeah, number 12 is the only one I didn't.
So number 12 is you have this triangle right here. Quiet, please. You have this piece right here. You're told this is 6x, y 3, 4, and 2. And then you're told that this is parallel to, or that's congruent to that. If that's congruent to that, what do you know about these two lines? Yes. You can't solve it. I'm giving away 5 points of extra credit. So
no, we're making sure they asked it right, because they asked Miss Julie.
Don't tell her not to give them the answers.
Okay, but they said that it equals like 1 or is it 6?
Every letter is one unique. Now, like once you figure out A is, A stays A the entire time, but it's 0 through 9. Every letter stands for one number.
Yeah, but the solution, like.
The solution is you got to tell me what A, B, C, D, and E are.
Yes, but we're saying so like it's.
If E is the number, I don't know, I'm picking a number 1.
But how many E's are?
Oh, 6.
Okay. Okay. For 1.
All right. That took you a while to ask that question. All right. Okay, here we go. If this is congruent to this by the converse to the 2 lines cut by transversal, now we know that this line is parallel to this line. So therefore, I know that this angle is also congruent to this angle. Therefore, I have 2 triangles, the small one and the larger one, where these 2 angles are congruent and these 2 angles, they're similar by the angle-angle postulate. Okay? All right, so now all it is just set up proportions. What you need to look is on both triangles, you got to figure out 2 sides that correspond that you got numbers to. I got a 6 and an X. I don't have 2 numbers. I got a Y and I got a this. I don't have 2 numbers. I need 2 numbers. 4 and not 2, 4 and 6, because 4 is on the small, 6 is on the big one. So the scale factor small to big is 4 to 6. Now we're just going to go piece by piece, which one you want, y or x. Okay, let's do y. So y would be on the small one, and the larger one would be not 3y, 3 plus y. Okay, you guys picked that one. I would have picked x because there's nothing, it's just 6 and x. But this will still work, cross multiply. There's your 6y, and that would give you distributive property. Plus, okay, move the 4y to the other side. Therefore, y is 6. Do the same thing for this, except for small piece is 6, and the other one is x. Therefore, x is. Can you do that in your head?
I can't remember.
6 times 6.
46.
36.
Divided by 4.
Sweet. I was 10 off. It's not that bad.
9.
There you go. You just did it. All of those are done exactly the same way. All right, it is a Friday, so all I do is ask questions and then collect the homework.
I'm sure that's not true.
What now?
On Friday.
Only if it's a really short. Today's not a short class, so if it's a really short class, then I can go over every single one. But
Come on, pass anything out.
all right, any questions about semester finals? As I said before, and I still haven't changed it, I'm sorry. This should say semester final. We're not going to do algebra review number 7. That'll be the first thing we do when we get back after Christmas break. So that's going to be semester final review. We're going to do 3 semester final reviews. Your test for me is on Wednesday, bright and early in the morning. I will not see you on Tuesday. So if you have any questions, no, certainly I'm not going away. So if it's after 12, you can come in here if you need help on something. Here is your homework. Hey, you never have to do that. You just, I'm not one of those teachers that says, oh, I hate those things. You hate those things? I think what it is, you like those things, so it gives you something to play with during class.
Just put it in this.
What?
To make him deal with it.
Why do I have paper all over my floors at the end of the day?
That's not me. That's not me.
I didn't get
That's
the
like
best and I
here,
created
that's
that
like
comment.
yeah, that's like here when we get into Western Pacific.
Right. All right. So homework over the weekend is 1 through 11, all on page 266. Today is medium day. It's not hard. I'll just say the reason why I say that this chapter is the harder one is because I will get kids that can't wrap their head around the fact that you got this thing about congruency and you have this thing about similarity. And the problem is you're going to see it today. We're going to get those letters that we saw in congruency before, SAS, except it's not going to be congruency. It's going to be similarity. Okay, and that's typically why kids get confused on this one. They're like, well, I already know how to do SAS. It's a different SAS. Okay. Here we go. So theorems for similar triangles. We've already got, well, we don't have a theorem, we're going to postulate. First postulate we have is angle-angle similarity. All right, so remember where we're at. We're trying to prove that not the 2 triangles are congruent, but that 2 triangles are similar. Right? I start off my class by saying the similarity is PowerPoint analogy here is that when you have 2 shapes of the same shape but different sizes, in math we call this similarity. We use this prime notation to illustrate when things are similar. So if you go from small to big, so we don't say C goes to C, we say C goes to C prime. The consequences, there's 2 of them. When 2 shapes are similar, right? That means polygons that when their vertices are placed or paired up exactly, we get 2 of these, right? Their angles, this is also why it's confusing. Their angles are congruent. We saw that yesterday when we did the angle-angle similarity postulate. All the angles are the same, and or corresponding angles are the same, but the sides are in a proportion. Last night, and what you just saw me do right up there, that's what I did. I did a proportion. This is not congruent triangles. These are similar triangles or similar polygons. Okay. Lastly, we use that little tilde symbol for similarity. So this is what you typically see. They give you two shapes. They say by this similarity statement that the two shapes are similar to each other. If that's the case, then the corresponding angles are congruent. So C goes with C prime, A goes with A prime. I'm getting that not necessarily from the shapes, but from the similarity statement. It's easier, more accurate, okay? The sides, however, are in proportion. So if I pick the first and the second letter, AB, that will be over AB prime, right? AC will be over AC prime. CB or BC will be over CB prime. All right, that's stuff that we've all seen before. Do you remember this from that first day that we did similarity? I gave you these two quadrilaterals. We figured out the scale factor. We calculated this. We have homework many times now. Some variables, and then we did the perimeter, and we found that the scale factor and the ratio of the perimeters are exactly the same. And this is a question I want to say 16 on that one homework assignment. So the big story here, I'll just show you the work that we did on that one day. The big story is we found out that if you have similar figures, that the scale factor, remember that's just by taking two corresponding sides and setting up a ratio, 20 over 30, that's 2 over 3, that if you did that to their perimeters, you get exactly the same thing. Why? Because, well, you're doing distances, okay? Last class, we proved that two triangles were similar. We got that through the angle similarity postulate, postulate 15. That's where we stand. Today, we're going to get a couple more theorems. We're going to do one proof. I don't have time to do the second proof. It's just too complicated. But I will say that it can be proven. I remember I said that in geometry, it's important that I prove everything to you unless I run out of time. All right, so here come the confusing theorems. And they're only confusing because they look exactly like the congruency theorems. We're going to get an SAS Similarity theorem. But we also have an SAS congruency theorem. They're two different, I don't know, opposite sides of the road, so to speak. One talks about when two triangles are congruent. One talks about when two triangles are similar. They also, even though they're both called SAS, mean completely different things. That's why they're called confused. This is the hardest proof that we've done yet. Hardest by meaning like, I would never have come up with this by myself. It's not hard in the actual proof. The proof is actually fairly simple, but the logic behind it really requires you to wrap your head around what's going on. So let's do it. All right, this is box number 1. So I have two triangles. We're trying to prove that they're similar. The only thing that I'm given two things is that two of the angles are congruent. That's A and D. And that two of the sides are in proportion. So I got the left side AB of the small triangle, and it's proportional to the left side of this one. And I got the right side of the small one proportional to the right side of the large one. So all we're missing is the fact that if we could get this third side proportional and prove that the other, or at least one other angle was congruent, we would be there. We could say they're similar. By the way, that's what we're going to do. This is a pretty slick proof. And it's hard to wrap your head around the very second to the last step. The rest of the steps are pretty easy. Okay, seems an impossible thing because there's no numbers up here at all. I mean, how do you show that angles are congruent or sides are in proportion if there's no numbers involved? So this is what they do. Now, for the sake of argument, we're gonna say that one of these triangles is smaller than the other, and it doesn't matter which one. I'm going to pick that DEF is the larger one. If DEF is the larger one, right, then there must be some point alongside DE. Stay with me. If DEF is the larger of two triangles, there must be some point along DE that is equal to AB. Watch my fingers. Well, there's AB. If I place it over here, there must be a point right here so that AB would be equal to D in this point that I'll put right here. We'll call it X. So that's what I'm going to do. I'm going to make an X on this side such that DX is congruent to AB. This is the, where did this come from? Yeah, a person way smarter than me came up with this. How can I do that? Well, that's just a basic construction. Okay. That was easy. I'm not sure why I did that. The next thing we're going to do is one more construction. I'm going to construct a segment from X all the way across the triangle that's parallel to EF. Okay? I'm going to construct a segment from X all the way across to a point, we'll call it Y, such that XY is parallel to EF. Okay. Why can I do that construction? Now I'm going to ignore this triangle, and I'm going to look at this triangle. How many triangles do I have over here? How many? 2. I got a small one, I got the big one. I'm going to show you that the small one is similar to the big one. I'm ignoring this one right here. Pretty easy to do, and it's because I made these 2 parallel. Notice both triangles have D in common. I'm ignoring this one. Both the small one and the large one have D in common. Okay, there's your A. Hey, what do we know about 2 parallel lines cut by transversal? What? Which angles? And he chose these 2. He could have chosen those 2 as well too. It doesn't matter which. Because remember, if I want to show that this one is similar to the big one, you show me the 2 angles. I've already shown that D is. Now, because of the parallel lines, I can say that those corresponding angles are congruent. So I literally chose the same ones he chose. Therefore, I can now say that the 2 triangles, this one, I'm ignoring this one, that this triangle and the larger one are similar. Why? Because of the angle-angle postularity theorem. Postulate 15. Everybody with me? And that's like I said, the logic isn't hard to understand. It's the who came up with put these 2 points here. That's genius. Okay, great. I just showed that another triangle that I didn't even care about from the start is similar to this one. Well, here's the next thing I'm going to do. I'm going to show you that this smaller one is congruent to this one. And if I can show that, then I can do substitution and substitute the 2, and I'm there. Because I already said that this one is similar to this one. So all I got to do now is show that this one is congruent to this one. I'm pointing e-learners to the 2 small triangles. And then we're kind of done. Okay. Well, notice we already have from the given that A is congruent to D, so I got an angle. Remember, to show that these 2 triangles are congruent, I need an SAS, SSS, ASA, AAS, or how about hypotenuse leg. They're not right triangles. How am I going to do that? This is pretty slick. So once again, ignoring this one, I'm going to set up a little proportion right here. I'm going to show that dx, right, that would be this on the small one, must be in the same ratio as the long one, and that this side, dy, must be equal to that one. I showed that this one's similar to that one, so I can make that statement, right? That allows me, similar triangles are proportional sides. Okay, that's cool. Boy, is this slick. I sure wish I could have come up with this. You see this one? You see this one? Do you notice anything they have in common? Both have the same denominators. I got a DE and a DF, a DE and a DF. Wait. DE, DF, DE, DF. What's this say?
You can substitute.
If I see an AB, I can substitute a DX or vice versa. Well, I got an AB and I got a DX. Therefore, I can say dy is the same as AC. Why? All I got to do is this substitution right here for either one.
Wait. Same as AC?
What now?
So it was the same as AC.
dy is the same as AC.
Oh.
Notice this piece and this piece. Why can I do that? Because I can change this dx to an AB and I get this thing right here. Or vice versa, I can change this AB to a dx and I get this thing right here. Therefore, dy must be congruent to AC. So we got to write what we just wrote. dy is congruent to AC. Boy, is that slick. I couldn't have done that. All I did was a little bit of substitution. We're almost there. I got an S and I got an A. I can do the same thing. I kind of ran out of space and squeezed them together. Right? I can do the same thing with the other side. By the way, remember, you already set up the fact that this side was congruent to that side. Where did I get that from? Right here. So I got an SAS. Therefore, big logic. If this is congruent to this, I'm pointing to the 2 small triangles, e-learners. If this is congruent to this, And on the one that we constructed that second triangle, that this was similar to this, using a little bit of a substitution, we can now say that the two are similar. That's crazy slick. And the question is, what in the world just happened? Well, let's see. I'm going to erase everything here. And let's see what we just proved. We proved that if you have two triangles where
One angle's current to the other.
and this side is the same ratio of that side, and this side is the same ratio as that side. That's the given, that the two are similar. Guess what we're going to call this? Side angle side. Now, it's got to be the two sides and the included angle, but it's not called congruent. We didn't show that they're congruent. I didn't show that the big one's congruent to the small one. I showed that they're similar. So this is where the confusion comes in. It's not, we are going to call it exactly the same. We're going to call it SAS, but it's for similarity. All right, write this one down, Book of Truth. Yay. Usually I get a couple kids like, hey, I really don't know what you just did right there. All right, this is called the SAS Similarity Theorem. A lot of words. If you have two angles congruent, and you have to have the included sides, or the two sides and the included angle, the sides aren't congruent. They're in a ratio, and they're in a proportion. If you have that, then you conclude that the two triangles are similar to each other. This is called SAS. So now we have two bullets. We got angle, angle, and now we got SAS. I want to leave a lot of time to do some practice problems, not spend time on proving stuff. We got angle, angle, now we have SAS. But neither one of those says congruency. They all say similarity. You'll get the impression that we'll have an equal 5 number of these similarities. We won't. We'll only get a couple of them. We'll have 5 for congruency and 3. Is it 3? 3 for similarity, I believe. Yeah, 3 for similarity. Monday's the hardest day of the chapter. Okay. If this is true, then you conclude that the two triangles are similar. Everybody good? All right. There's one more. I said that I don't have enough time to prove it today. We only got 15 minutes left, and I want to spend some time doing practice problems rather than proving this. Trust me, and by the way, it's solved exactly the same way as the previous proof. Here's the setup. We got two triangles, and all of the sides are in proportion. Guess what we're going to call this one? If all the sides are in proportion, we're going to call this one, we're going to call this SSS. Okay? And it can be proven, and just to show you, it's done literally the same way. Or if you're curious, I'm going to leave all the steps up there so you can watch the video. If you say, no, I don't believe Mr. C, it can't be proven. Well, there's the proof right there. Okay? You guys are going to write this in your book of truth. So this is called the SSS Similarity. So this is our third and final bullet we have to prove that two triangles are similar. We got angle, angle, we have side, angle, side, and we have side, side, side. If the sides, it doesn't say some of them, it's the side. That means all of them. Danny, you got it all written down? Don't lie. Write it down. It's got to be in your book of truth. If the sides of two triangles are in proportion, that's all three sides, and the triangles are similar. Don't forget to put in SAS Danny too.
But we get an angle side.
Nope. Nope. On Monday we do a whole bunch of things with similar, but that we don't get any more theorems on triangles. And then I believe that's the last section of the chapter. And then we'll take chapter test. That is correct. So Monday's the last actual class of the semester. The rest is just review, test taking. We might, depending upon how Monday goes, we might squeeze an extra day of practice in as well too. All right, everybody good? All right, let's see how this works. So similar triangles, we got these three right here, angle, angle, SAS, and SSS. Angle, angle means you need to show that two angles are congruent. SAS, one angle congruent and two sides in their proportion, and SSS, all three sides in proportion. These are your three, I don't know, tasks to do if you want to say that any two triangles are similar. All right, so flip your paper to so you can see this. I had to do it sideways. It's on there. This is box 3. I said I wanted to devote most of their time to practice. So this is what homework will look like. Danny, you got your paper in front of you? You're looking at it? Okay, what does it say? All right, now I know you're on the right page. Okay, so we're trying to state whether or not these two triangles are similar. We got 3 bullets, angle, angle, SAS, and SSS. So let's look at the given information. Every single bit of the information involves what? Does it involve angles, sides, or a combination of both? Every little bit of that information involves sides. So you tell me, is it going to be angle, angle, SAS, or SSS? Going to be SAS, SSS, if it's even true. Here's the issue with similarity. It requires some calculator work, right? Because we got proportions. We, just like yesterday's class, we got to prove that the proportions give us the same ratio. So even though our hint or our suspicion is that this one's going to be true because of SSS, we haven't proven anything unless we do the math. So how do we do the math? We're trying to prove SSS because all we're given are side measurements. Well, step number 1, take your pencil, write in the information. RS is 18. ST is 15. RT is 10. WT is 6. ZT is 9. Oh, what did I write? ZT
is in the middle.
ZT is middle, so that we got 2 middles, notice. So one of them is 15 and one of them is, the shorter one is
9.
Yes. And then the last one we got 10.8. 15 looks horrible. Okay. In order to use SSS, we got to show that all the proportions are equal. So Danny, look at the 2 triangles and give me 2 corresponding sides. Those are angles. Give me sides. Those are angles. Give me sides.
Okay, SR and ZW.
Let's look at SR and ZW, right? I'm going to put those numbers in it, and once we make our one decision whether we go big to small, small to big, we stick with it. What do you want to go? Big to small, small to big? Go big to small. That would give me the ratio of what? 18 over 10.8. Everybody see that? Okay, and that's supposed to equal, all right, Cadence, give me another pair of corresponding sides. And you can get them from the similarity statement if you want to.
So RT, so 10 over WT, which is.
Okay, and the last one, Jenna? So what's the numbers?
So 15.
So our question is that true? This is going to be a calculator drill. Grab your calculators. You're going to need it for homework.
Oh, yeah.
All right, let's see if this is true or false. If it's false, they're not similar. 18 divided by 10, 10.8. 1.6 repeating. Boom. If they're all 1.6 repeating, it's true. 10 divided by 6. Oh, it's looking good. 15 divided by 9. Same thing. You just proved it. Now, for the e-learners, I apologize. I was writing some on the paper. But this is basically what we did. We set up the proportion, and I also chose big to small. We threw in the numbers, and we found that each one of these ratios gives us 1.6 repeating. It's true. What will typically happen is that you'll say, oh, look, they only gave me sides. It must be SSS. And then one of these numbers will be jacked up, and it won't give you 1.6 repeating. Now, it doesn't always get to be 1.6 repeating, but you get the idea. The ratios have to be the same. Questions on that? Okay, let's do another one. Yes, they are similar. All right, same problem as box 4. Same setup. I didn't want to do completely different ones. This time we got different information. Chris, what are we given for our information?
Triangle RST is similar.
We're trying to prove that.
Angle 1 equals angle 2.
So we got an angle, and we got two sides in a ratio / proportion. So you tell me which one do you think we would be using if we're given one angle and two sides. We would think it's side angle side. We got to prove it. I don't need to prove anything here. It tells me that they're, I got to prove that the ratios. All right. I left off the numbers. I apologize. All right. So this would be SAS. I should have put the numbers in, but yeah, that one's SAS. Everybody get it? Now, if you're given numbers for the sides, you got to ensure that that's in fact true. The fact that the ratio of WZ over RS gives you the same number as TZ over TS. All right, so this one says no. You want to know why? Because they tricked you. Let's see what it actually says. What's that?
I don't know.
Read what I circled. Read what I just wrote. WZ, where's WZ? Hey, remember, it's got to be the two sides between the angle, or the angle's got to be between the two sides. What's the second side? All right, so far so good, right? That one corresponds to that one. So that first ratio check, it's good. What's the next thing? TZ is right here, and what's the problem with that? It's not, if we're going to use angle 2, guess what we got to have? We got to use WT. They gave us TZ. So this is how they're trying to trick you and thinking, oh yeah, it's SAS, and it's not. We didn't prove anything. So we can't, at least from this information, prove that the two triangles are similar. Does everyone see what happened there? If in order for us to prove, we would need WZ and WT, because those are the two sides that are between angle 2 or form angle 2. We would need SR and RT. We didn't get that. So even though it looks like it would be an SAS, it actually doesn't do anything. All right. I'm not sure why that's so large. That looks strange.
That does look strange.
It's supposed to have a triangle.
Where is my triangle? I have no idea why it's like that. All right. Strange.
Magical property.
All right. So here's our triangle again. We're given that ST is perpendicular. ST is perpendicular to RW. So immediately that gives us what right here? Okay. We're given that ST is 32. ST is 32. And we're given that SZ is 8. SZ is 8.
SC is a little.
Sorry. Right there is 8. We're given that RT is 20. And we're given that WT is 15. All right, WT is 15. All right. Can we, from this information right here, we know nothing about 1 or 2. Can we prove that they are, well, notice we got an angle. So maybe an SAS. All right. You're going to say they are or not?
Oh,
It should be SAS. We still got to prove it. So with the numbers. All right. So clearly 20 goes with 15. That's why that big proportion is there. So 20 goes with 15. And what's the other ratio? And I went from big to small this time.
32, 8.
Nope. Nope. Look where 8 is.
Wait.
Subtract.
So were we given ST or we were given ZT? Let's go to the thing. We were given ST is 32. So ST is 32, so therefore ZT would be,
24.
well, I got 40 and 30 and 24. Which one is it? How far is it from here to here? That's where I'm going. All right. So the big one was 32, and the small one was 24. Okay, calculators. If those two are equal, we're good to go. It's SAS. 20 divided by 15, 32 divided by 24. So we proved it. You see why this chapter is a little bit more challenging? It's not as simple as, I mean, we never did anything like this for SAS before. We just looked at it like, yep, looks like SAS to me. Now you got to prove it. So this one is much more challenging. So it turns out this one is, yes, there's the math behind it. This one is. I have no idea why that's crazy. Well, I also, this is the same class I had last year. Why didn't I catch it last year? Or maybe I did and I was like, oh, I'll remember to change it, and I didn't change it. All right. In the remaining time, let's look at how this works. It says, can the two triangles be proved to be similar? Remember, we got AA, we got SAS, and we got SSS. Okay? I'm just going to say, I'm going to warn you. When they give you numbers, it's the one that requires the most work. You have to show that the ratios are equal. So let's ignore 1. That was too much work. Let's go to 2. 2 just has angles, so the only thing it could be, if they're similar angle. Are 2 angles congruent? Which ones? So this is, they're trying to trick you, right? 60 and 70? 60 and 70? Which would leave 60 and 70 is
130.
so that would leave us with 50. 70 and 40. So that would leave us with, okay, so similar or not similar? Are 2 angles of one congruent to 2 angles of the other? Not similar. Once again, guess what you immediately see here? And you also see vertical angles. So I got my angles, right? The issue is that I would have to, we'll do this one and call it a day. I got to show that the sides are in proportion. The question is this, which match up? Is it tops with tops, bottoms with bottoms, or is it top with bottom, bottom with top? Well, you got to use some logic here. I'm looking at the big triangle here on number 3. I got big side, small side. So that clearly that would match with, you go big side, small side, it would match with big side, small side. Where's the big side on the small one? 9. So that means the 12 would match with the 9, and the 8 would match with the calculators. Last one. 12 over 9, does that equal 8 over 6? You can also do cross multiplication. And see if that's, it's true, so that one is SAS. And you guys didn't have any time for the problem. I didn't think you would. All right, e-learners, any questions? No one is online, so we will end it there. We'll see you guys on Monday.